All right, so we're going to start looking at section 3.3, which is on trig identities. For the homework, most of what I give you is going to be worksheets. I think tomorrow is the only night we're going to do some from the book. Okay, but worksheets today and Thursday. All right, so first thing I want to just make sure everybody understands is what is an identity. Okay, specifically, we're going to work with trig identities. But first, I just want to make sure you know what an identity actually is. Right, so suppose we had two functions, okay, from algebra. I'm going to call them, one of them is function f, the other one is function g. Okay, these two functions are equal if you can plug a value into one function, plug the same value into the other function, and you always get the same answer every time in both functions. Okay. So here's an example of two functions that are identically equal. F of x equals 4x plus 8. G of x equals 2 times 2x plus 4. These two functions are exactly the same thing. One of them, if you look at it, is more simplified than the other. But if you pick any number you want for x, say pick 2, plug it into the top function, then take 2, plug it into the bottom function, I guarantee you will get the same answer in both. Okay? And that won't work for just 2. You can pick any number you want for x. Positive, negative, fraction, decimal. Plug it into the top, plug it into the bottom, you're always going to get the same thing. These functions are identically equal. Okay. Does anybody see what property you'd use on the bottom one that would make it the top one?
Distribute.
Yeah, it's just if you distribute out the 2, then you'd see they're really the same thing. Right? When we work with trig identities, it's not as easy as just saying distribute a number and see that they're the same. Okay? But that's basically the same idea. We're going to start with two expressions, okay, that are trig. One of them is going to be a simplified version of the other, and our goal is to take the one that's more complicated and make it look simplified. Okay, so an identity, basically, it's just an equation that's true no matter what values you plug in for the variable. Right, so if I were to take and write 4x plus 8 and now say equals 2 times 2x plus 4. Okay, in Algebra 1, you might start solving this by distributing out, combine your like terms, and usually you get an answer like x equals and you get a number. Well, in this case, you wouldn't get that because what's on the left and what's on the right is exactly the same thing. That's called an identity. You can pick any value you want for x and it will always work. Right, so any questions on what an identity is? It's an equation that's true for any value that you want. All right, so now let's look at some trig identities. Okay, the first 6 we're going to look at, you guys already know. We've talked about these before, cosecant, secant, and cotangent. Which trig function do you flip to get the cosecant? Sine. So if you take 1 over sine and flip it, you get cosecant. How about for secant? Cosine. Okay, and how about someone else? What trig function do you flip to get cotangent? Tangent. Yep. All right, so these are called your reciprocal identities. And these are true no matter what value you pick for the angle. Okay, they're always true. You can use a 10-degree angle, a 12-degree angle, negative 76.4. It doesn't matter. This is an equation that's always true. Okay, and I can also take and basically write these 3 in a slightly different way, but they're really the same identities. What do you think sine would be? It'd be 1 divided by... Yeah, cosecant. These top two are the same thing. Okay, all you've basically done is switch what was in the denominator. Okay, cosine, that would be 1 divided by secant. Okay, so if you flip the cosine, you get secant. If you flip the secant, you get cosine. You change it back. And lastly, what about tangent? 1 over cotangent. Okay, so if you flip the tangent, you get cotangent. If you then flip the cotangent, you get tangent back. So these 6 are your reciprocal identities. Really, the second 3 are repeats of the first 3. Okay, any question on those identities? Okay, the next 2, well, we kind of looked at this one yesterday. Tangent equals sine over cosine. Okay, that's a quotient identity. So tangent is sine over cosine. So what do you think cotangent would be? I mean, I know cotangent is 1 over tangent, but how about in terms of sines and cosines? Like what's the difference between tangent and cotangent? Okay, think of that, and then think about what would happen on this right-hand side.
Do you flip them?
Yeah, it flips. Okay, the only difference between cotangent and tangent is you flip them. So if tangent is sine over cosine, cotangent is cosine over sine. Okay, so using the reciprocal and the quotient identities, you can write every single trig function just using sines and cosines. You don't need to use tangent. You can just use sines and cosines. You don't need cotangent. You can just use sines and cosines. You don't need secant. We can just use cosine. And you don't need cosecant. We can just use sine. Okay, so all the trig functions we've learned can all be done with just sines and cosines. All right, and there's 3 more basic identities. All right, so what you might want to do is leave a little bit of space at the bottom here. Tomorrow we'll add the last 3, but then you can put them all in the same spot. So we'll study the last 3 tomorrow. Right, we can also use the tangent and reciprocal identities with higher powers. Right, so we said that tangent is sine over cosine. Well, tangent squared would be sine squared over cosine squared. Okay, just basically putting a power of 2 on everything. How about tangent cubed? What do you think tangent cubed would be? Sine cubed over cosine cubed. Generally, we're not going to do problems that have powers as high as 3. We'll do some with 2, but usually not 3. Okay, and you can do this with as high of a power as you want. Okay, what about cosecant squared? Okay, look at what cosecant was. And what do you think cosecant squared would be?
1 over sine squared.
Yeah, it would be 1 over sine squared. Cosecant cubed would be 1 over sine cubed. Right? So you can use the reciprocal and the quotient identities with as high of a power as you want. Okay. Questions on that idea? Okay. All right, so what we'll do is we'll look at some examples, and then I'll show you 3 basic techniques for taking something that looks complicated and making it look simpler. All right, so the first thing we're going to look at is secant times cosine. Okay, somehow this is going to simplify. Okay, and one trick we can use to simplify a trig identity is to take everything that's not a sine or a cosine and rewrite it as sine and cosine. Okay, we said that earlier. We can write anything you want just with sines and cosines. And a lot of times if you do that, things will cancel out. If something is already written as a sine or a cosine, we're going to leave it. Okay, in this problem. Just leave it. Okay, so let's start with secant. Okay, how do I write secant? Just using sines and cosines.
1 over cosine.
Yes, secant is 1 divided by cosine. Any question on that? Now I'm going to write times cosine. I don't have a denominator, so Nick, what can I put as a denominator? I could just put 1 if I want. Okay, and John, when I multiply these together, what happens?
Everything cancels out.
Yeah, these cancel out, so what am I left with?
1.
I'm just left with 1. And that's the answer to that identity. So if you take the secant of any angle and multiply it by the cosine of that same angle, the answer will always be 1, every time. Right? So now if we had a calculus problem and we had to do something with this, it's a lot easier to work with the number 1 than it is to work with this secant times cosine. Okay, this is much simpler. Okay, questions on that one? Okay, not every problem is going to simplify to a number. Sometimes you're still going to be left with a trig expression. Okay, it's very rare that everything cancels out. This one did. Okay, let's try this one. Okay, cotangent divided by cosecant. Okay, first thing I want to look at is just try to figure out what I'm going to change and what I'm going to keep, if anything. Okay. Do I want to change the top? Yes. Okay. Andy, do I want to change the bottom?
Yeah.
Yes. Here, everything is going to change. Okay, I'm not going to keep any of this. Okay, let's start with the top. Okay, if we go back and look at cotangent, we have a couple ways we could do it. We could write it as 1 over tangent, or we could write it as cosine over sine. Which way is correct? Well, depends on the problem. Okay, this is where trig identities get tricky. There's lots of ways to solve them. Okay, how do you know which way to do it? Just experience. Okay, so after practice, you get better at it.
Do you have like the homework for tonight? And you're just gonna put this on.
Yep, it'll be online. All right, so in this case, which way do you think I want to write this? Do I want to write cotangent as 1 over tangent? Or do we want to write it as cosine over sine? Yeah? Yeah, we do. We want to write it as cosine over sine. Okay, and the reason why is going to come in the next step. Okay, so doing identities is a little bit like playing chess. You kind of have to know what the move you're going to do after the one is you're doing now in order to figure out what you should do now. Okay, which is why chess is confusing sometimes. Right? But I already know what's going to happen to this bottom. And I already know what's going to happen is going to make something cancel in the top. That's why I chose to do it this way, or Callie chose to. All right, so now let's change the bottom. What's cosecant? Yep.
1 over sine.
That's 1 over sine. And now we have two fractions with the same denominator. What happens with those denominators? They cancel out. So what am I left with here?
Cosine over.
Yep, just cosine over 1, which is just cosine. Okay. So if you take the cotangent and divide by the cosecant, it's exactly the same as just doing the cosine. Okay. Complicated expression on the left, simpler expression on the right. Okay, questions on that one? Okay, another one very similar to the last two. Cosecant times tangent. How about Brandon? How can we write cosecant as a fraction?
1 over sine.
Good. 1 over sine. Okay, and Kaylin, how can we write tangent as a fraction?
Sine over cosine.
Right. She picked sine over cosine. We also could have done, there's another way to do it, 1 over cotangent. If you do 1 over cotangent, you're going to get stuck here. You're going to look at it and you're going to be like, I can't figure anything out. And that's because you changed it using the wrong formula. In this case, sine over cosine is perfect because, Analia, what's going to happen now?
Because the signs are going to cross out.
Sines are going to cross out. And I'm left with 1 divided by cosine. Okay, and if we go back and look at our list, what is 1 divided by cosine? That's the secant. Okay, so how do you know when to stop? Why not just stop at 1 over cosine? If we can get rid of the fraction, we usually try to. Okay, not every problem you're going to get rid of all your fractions. Okay, but we're starting out with easy ones. Okay, questions on that one? Okay, so this one says 1 minus cosine squared divided by 1 minus cosine. How come our trick we've been using up until now won't work? Change everything to sines and cosines.
It's already all cosine.
It already is. Okay, everything here already is sines or cosines. So that trick's not going to work on this problem. Another trick we can use, and we've used this trick before, conjugates. Okay, when did we use conjugates? Anybody remember when we did that? Yeah, we used conjugates just last week. What did we do last week with division that we didn't like to leave letters in the denominator? We wanted this letter to cancel out. Remember what letter we worked with last week? Complex numbers. Right? Anytime we had something like this, the way we simplified it was to multiply the top and the bottom by the conjugate of what was in the bottom. We're going to use that exact same trick we've already used before, except now we're going to do it with a trig function. All right, so what's the conjugate of what's in the bottom here? Nick? 1 plus cosine. Okay, remember, your conjugate, all you have to do is change the sign of the second part. So if you have 1 minus cosine, conjugate is 1 plus cosine. Okay, so let's multiply top and bottom by that. Okay, and I'm going to write the answer down below. Okay, when I do this out, I'm not going to do out what's in the top. I'm just going to leave it as 1 minus cosine squared times 1 plus cosine squared. Okay, the reason? I already know what's going to happen in the next step when I FOIL the bottom out. If I multiply out what's in the top, I'm going to get stuck. I won't be able to finish the problem. All right? So how do I know that? Again, it's just practice. So leave the top just the way it is. 1 minus cosine squared times 1 plus cosine. Okay, in the bottom, we're going to do it out. Okay, and you FOIL it just like you'd FOIL it with anything else. So we'll start, what's 1 times 1? This is the easy one. Yep, 1. All right, what's 1 times cosine?
Cosine.
just cosine. What's 1 times negative cosine? Zach? Negative cosine. And lastly, we have negative cosine times positive cosine. Well, just start with what's a negative times a positive? Negative. And what's cosine times cosine? Cosine squared. Okay, what happens in that denominator? Just look at what we have written. Yep, Jake.
2 cosines in the middle of the cancel out.
Yeah, we have plus cosine, minus cosine. They cancel out. So Jacob, what's left in the bottom?
1 negative cosine squared.
1 minus cosine squared. Okay, so in the top, I have 1 minus cosine squared times 1 plus cosine. In the bottom, it's just 1 minus cosine squared. Okay. Now, look at what I have, and what's going to happen there?
The 1 minus cosine squareds are going to cancel out.
The 1 minus cosine squares are going to cancel out. That's why I did not FOIL what was in the top, because I knew in the second step, this and that were going to cancel out. The answer is just 1 plus cosine. Okay? There's nothing else you can do with that. Okay? Everything's a sine or a cosine. You don't have any fractions. It's just cosine plus 1. Can't simplify that anymore. Okay, so we started out with something that had cosines to higher powers, had denominators, fractions, and we ended up with something pretty simple, 1 plus cosine. Okay, so we're going to see this trick come up, multiply by the conjugate. Okay, any questions on what we did there? We're going to do the same thing again here pretty much. Okay, since we're only studying certain kinds of problems, after a while, you'll be able to look at this and recognize what kind of problem it is and what you should do. Okay, the first thing I look at here is the secant. And I say, well, should I change that to a sine or cosine? Okay, but then I look at what's in the numerator. I see 1 minus something squared. Anytime I see that, and then I see something like 1 plus sign in the bottom, I'm thinking if I use conjugates, I'm probably going to get something to cancel out. Okay, so let's try it and see what happens. All right, what's my conjugate here, Nathan?
It's for the top or bottom?
Always the bottom.
It's 1 minus sine.
Yep, 1 minus sine. So we got 1 minus sine and 1 minus sine. Do you think I want to FOIL out what's in the top? No. If you do, it's going to be a mess. If you FOIL things out and you're going to end up with a power of 3, I would wait. Okay, that's probably going to cancel out. All right, so leave the top, okay, just the way it is. Secant times 1 minus sine squared times 1 minus sine. Okay, now let's do out what's in the bottom. So Tiffany, what's 1 times 1?
1.
Yeah, 1. Okay, and Derek, what's 1 times negative sine? Since you're just multiplying by 1, does multiplying by 1 change anything?
Negative. This is negative sine.
Yeah, just negative sine. Okay. How about 1 times positive sine? Positive sine. So what's going to happen here is we get negative sine, positive sine. They cancel out, just like they did last time. And the last part, positive sine times negative sine. Okay, Jackie, what's a positive times a negative? Negative. And what's sine times sine? Sine squared. So that whole part cancels out. Okay, any questions so far? All right, now we're left with secant times 1 minus sine. Okay, so now at this point, we have to ask ourselves, is it as simple as it can get? Or could we try changing things to sines and cosines, and maybe we can get rid of this distributive property? Okay, we can try it. If changing things to sines and cosines makes it worse, then we'll just come back and we'll stop here. Okay, but let's try changing to sines and cosines. Okay, what is secant in terms of sine or cosine? That's 1 over cosine times 1 minus sine. And now, what property would I have to use to get rid of this on the outside? It's distributive. Okay, so multiply it out, and let's see if something cancels. If it does, that's good. If it doesn't, then we'll go back and leave it the way we had it. Okay, so we have 1 divided by cosine times 1. That stays the same. So since it stayed the same, maybe it wasn't worth changing it, because before it wasn't a fraction. Now it is. We'll see. Okay, and now this part, you're going to multiply 1 over cosine times sine over 1. Okay, what's 1 times sine? Sine. And what's cosine times 1? Cosine. Okay. Now when I look at that second part, I do see something that can happen. Okay, we have sine divided by cosine, but there's an easier way to write that. That's just tangent. So this last part is just tangent. And what could we have kept the first part as? We could have just kept it as secant. Okay, so that one was a little harder. Okay, that's more of like a medium one. Okay, there was a lot of steps in that. But I would argue that this is simpler than that. Okay, the reason? It's just secant minus tangent. Here you've got a distributive property you have to do out. Here you don't. Okay, any question on that one? Okay, and what I'm going to do for a lot of problems on the test is I'm going to tell you what you start with. I'm going to tell you what I want you to finish with. So you're going to know where to start. You're going to know where to stop. You're just going to have to show me the steps in the middle. All right, so there won't be any question. Should I just stop here or should I keep going? You'll know. Okay? Okay, any questions on that one? Yep?
How do you get the tangent part at the end?
Tangent? So this part, you can go back in your notes and look up what's sine divided by cosine. Go back and look it up. Sine divided by cosine is tangent. Okay. So we're using one of these 8 formulas for every part of a problem. Every problem we do today. And you're using all the properties you guys already know from Algebra 1, like distributive property, FOIL, combine like terms, that kind of stuff. All right, this one's a little different, but if you see what to do right away, it's extremely easy. It's one step, the whole problem. If you start doing it the wrong way, it gets pretty bad. Okay, you're going to end up in a mess. Okay, start with sine over cosine. Does anybody recognize what that is? Yeah? That's tangent. Okay. Notice I switched, I'm using x now before I use theta. That doesn't matter. It's like in algebra 1. You can use x, you can use y, whatever letter you want. Plus, now look at 1 over cotangent. What's that? Yep. That's also tangent. Okay, the first one is tangent, the second one is tangent. If you add tangent to tangent, how many tangents is that? 2. Tangent. Done. Okay, that's the whole problem. 2 times tangent x. Now, if you started changing cotangent to something like cosine x over sine x, okay, now you've got a fraction over a fraction, and you've got to deal with that. And there's other ways to do it, but this is definitely the simplest. Okay, so this time we actually changed it to tangent, not sines and cosines. Okay, but it made it a very short problem. Questions? All right. And one more type. All right, so this one says 1 plus sine over sine plus cotangent minus cosine over cosine. Okay, this is going to be the hardest one we do today. But it's going to use all the same formulas that I gave you very first page of notes. Right. When I look at this one, I see 2 separate fractions and I'm trying to add them up. What do we usually do if we want to add 2 fractions together? We got to make sure something is the same. Yeah, the denominator. Okay, if you want to add 2 things together that are different, you need a common denominator. And that's the trick here. Okay, find a common denominator. Chances are, if you do that and you do it correctly, somehow stuff is going to cancel out. Okay, so if we had 2 fractions like 2/3 plus 5/4, one way to get a common denominator is just multiply the 2 you have together. So in this problem, common denominator would be 12. Okay, what's the common denominator going to be in example 5? It's going to be sine times cosine. Okay, there's nothing else we're going to do with that for now. Just leave it as sine times cosine. So sine times cosine. Okay, now look at the fraction on the left. What is this denominator missing to make it the common denominator? What is this denominator missing? It's missing cosine. So I'm going to multiply the bottom and top by cosine. All right. Now, what is the denominator on the right missing to make it the common denominator? It's missing sine. So I'm going to multiply the bottom and the top by sine. Okay, just like if I was doing this problem, I'd say, what is the denominator here missing? It's missing the 4. So I multiply top and bottom by the other denominator. Same thing here. Bottom and top by the other denominator. It's exactly what I just did here. Okay, I haven't decided yet if I'm going to distribute that out, if I'm just going to leave it not distributed. I don't know. We'll see what happens. I think I'm going to distribute it out. Okay, I looked at what's going to happen if I distribute here and at the end, and there is something that's going to cancel out. All right, so let's distribute and see what we get. Brandon, what's cosine times 1?
Cosine.
Okay, we get cosine. Zach, what's cosine times sine? Don't think too hard about simplifying that.
Okay, cosine times sine.
Just cosine times sine. Yep. that's the first part. Okay, let's look at this one. Okay, for now, just leave it as cotangent times sine. You might think of something you can already do in your head, but don't do anything yet. Just write cotangent times sine, right? And that's positive times positive. That's positive cotangent times sine. And the last part, this is the part that made me decide I should distribute it out. I have another cosine times sine. But what is it this time? It's negative. What was it last time? Last time it was a positive times a positive. This time, positive times negative. When that happens, things cancel. Okay, so it's negative cosine times sine. Right, so minus cosine times sine. So I had a positive cosine sine and a negative cosine sine. That's all gone. Any questions why that canceled out? Okay, you could try to do more at this step, but what I like to do is just rewrite what I have now cleaner. Okay, I've gotten rid of all that stuff. Let's look at it now with that stuff gone. So we got cosine plus cotangent times sine all over sine times cosine. Okay, anybody see what I can do in the top here? I can cancel something out if I change something. Yeah, I can change cotangent. Everything else is a sine and a cosine. What can you change cotangent to? Yeah, I'll just change it right here. Cosine divided by sine. And now if you multiply cosine divided by sine times sine, what cancels out? The sines are going to cancel out. This sine is in the bottom. This sine is in the top. Okay, so now in the top, I've got cosine plus cosine. What's that? 2 cosine. So 2 cosine divided by sine times cosine. Is there anything else that's now in both the bottom and the top? Cosine. That cancels out. What am I left with now? I'm left with 2 divided by sine. Or you could think of it this way. 2 times 1 over sine. That's exactly the same thing. 2 times 1 is 2. 1 times sine is sine. And what trig function do you get if you flip sine? You get cosecant times 2. Okay, so we started out with that extremely big expression. Okay, had all these denominators, different denominators, numerators, all this complicated stuff. It had sine, cotangent, cosine. It had 3 different trig functions in it. Okay. By the time we were done, the whole thing comes out to 2 times cosecant. The whole problem. Okay, this is a hard one. Okay, a lot of steps here. We used common denominators. We used the trick of changing things to sines and cosines. We did distributive property twice, so we had to use that. Okay, we combined like terms, so that's a 4th thing we did. And we had to use the identity for 1 over sine, which is cosecant. Okay, so a ton of stuff going on in that problem. Okay, not the kind of problem you get the first time through. Okay, it's definitely one you got to look at it, do it again, and try to understand it on your own. Okay. Any questions on what we did today for trig identities? All right, so a lot of the identities, even the ones that you think are simple, like this one, and I did this in with you guys, it was like 30 seconds. This is a problem some people will get stuck on for 5 or 10 minutes because they just won't see the trick to do it. Every problem here has a trick that makes it easy. If you don't see it and you get stuck, sometimes it's better to just start over. So you know what, maybe I did something wrong at the very beginning. I'm just going to go back and try something else. Okay? But there is a trick to every one of these problems, okay, to make them reasonably fast. Okay, so don't forget about your conjugates, changing to sines and cosines, and writing things with a common denominator. Okay, those are the three big tricks. All right, so homework tonight will be a worksheet. Okay. I'm going to give you guys a little time to start on it now.